I suppose we're. Whoa, whoa, whoa! Just went live. I saw it go. I wailed my mic. Oh, okay. I think I'm back now, right? Are we good? You got me? Happy Bow Tie Friday. How's it going? Hope everybody can hear me. I think it's live. I'm not sure yet. There it is. There it is. There it is. Yeah, yeah, yeah. Oop. Yes. Okay. All right. We are going. Okay. What's up? I'm Austin Griffith. I am a builder and an educator in Ethereum. I'm always trying to come up with some fun, weird build, and we'll try to do the same thing today. I'm both a builder and an educator, but also a little bit of a funder too. We're always trying to find up and coming high impact builders and get them UBI. So always doing lots of things here. But let's jump in. Today we're talking about building apps. We're talking about building apps quickly on Ethereum. So let me share my screen and we can start with Speedrun Ethereum. So Speedrun Ethereum is a great place to get started. It's going to help you get get the basics, get an understanding for what kind of things you would build on Ethereum. Not just how to build on Ethereum, but what to build on Ethereum. Let me make sure. Oh yeah, my mic is not. Get the mic back to the Yeti. There we go. There we go. I bet the mic is a lot better now. Hopefully that sounds better. Okay, so Speedrun Ethereum starts with a simple NFT app. You build a collectible, you send it around, you learn about burner wallets, you learn about Scaffold ETH, and then it really gets into like a decentralized staking app, and it teaches you how a a group of people that don't trust each other, right? So people who don't trust each other, you build an app that lets them coordinate without having to trust each other or even some centralized system. You only have to trust the code. You have to trust that Ethereum will do what it does. And if you write the smart contract correctly with the correct rules, folks can participate in that smart contract kind of globally, publicly, censorship resistantly. I don't even know if that's a word, but they can coordinate financially to make something happen. And I think that's a key takeaway and an aha for building something on Ethereum. And you'll get those learning moments along the way with Speedrun Ethereum. There we go. We got speedrunethereum.com into the notes. Sweet. You will go farther. You'll learn about randomness, right? You'll build a dice game, and then you'll build a smart contract that attacks that dice game. So basically, it sets up so it only rolls the dice if it's going to be a winning roll. And shout out to Chainlink here. You will also probably learn a little bit about oracles and how you can get randomness from VRF from Chainlink. Okay, one of the biggest, like the decentralized staking app is like this big aha moment. Kind of the next big aha moment is going to be building a DEX, learning how to build a credibly neutral smart contract that lets people swap between those tokens. Uh-oh, I lost my screen. Did I do something wrong? There it is. It's back. We're back. Building a DEX will teach you how to create a hyperstructure, basically. You're building a smart contract that's credibly neutral, that has no censorship or censorship. It has censorship resistance, and you're able to build up reserves, right? It's the reserves within the DEX. They allow people to swap, and the more reserves you have, the better the swap. And so you want to incentivize folks to put in that liquidity. So you have this fee market that's built in. So you have these expansive fees that are rewarding liquidity providers that are providing liquidity so people can swap totally permissionlessly within this DEX. You're building a hyperstructure, and that's really neat. And that's another thing that you'll learn along the way with Speedrun Ethereum. Again, it's teaching you not just how, but why you would build these things on Ethereum. And you'll see state channels, multi-sig wallet. You start learning about, this is even kind of like the tipping point for account abstraction and a lot of other things. And then you build a silly little SVG NFT. So that's Speedrun Ethereum. And right now, Speedrun Ethereum is based on Scaffold ETH. Scaffold ETH is an older tool now. It's vanilla JavaScript. It's really good for noobs who are totally new, just trying to get in, figure things out. It's a little bit bloated. It has all the things you need, kind of. And so with Scaffold ETH 1, there's just a lot there. but it's really handy to get in and start tinkering. Honestly, the combination between Scaffold ETH1 and Solidity by Example, being able to grab something from Solidity by Example, throw it into your smart contract and tinker. This was a huge help for me personally, but I think a lot of people, a while ago, and we'll show how Scaffold ETH2 is kind of the next evolution of this, and I'll build something quickly with it soon. So yeah, there's the link to Scaffold ETH. Let's throw the Solidity by Example link in there too. We'll get to that in a second, and then finally let's throw this Scaffold ETH2 link in there. That's the main thing I'm going to be showing off today. And by the way, go ahead and just like ask questions in the chat. I'll kind of just like try to field them as we go. But also, like at the end, we can kind of do some Q&A too if there's time. I think there's going to be a lot. I feel like an hour is a long time to be building something. But anyways, so here we go. We're going to get started. We're going to start from complete scratch with Scaffold ETH2. So we're going to go grab Scaffold ETH2. I think it's in the notes. Yeah, it is. Rad. Okay, here we go. So a lot of GMs in the chat. Very nice to see. I'm going to start out by, let's see, I'm going to go to Scaffold ETH2 and I'm going to create a new repository using Scaffold ETH2 as a template. Let me maybe zoom in a little bit more here. Let me go back and do that again. So right here, this big green button, let's create a new repository. So I've got this idea. I want to make like a stupid staking app, like literally stupid. It's going to be like, I want to test what would happen on mainnet. So I don't know what would happen if I did this, but I want to put a contract up and I put a little money in it. And then I want to set the rules. So if you put a little bit of money in it and you wait an hour, you can take out a little bit of money plus a little bit more. And so it's like free money. And I want to see if like bots would attack it automatically or figure it out or not. So let's just say we want to experiment with this idea. Let's see if we get to it in time. We have some time to go, but I'm calling this stupid staking, I think is what we're gonna, what we're gonna go with. Yep, and we're gonna make it public, and we're gonna create the repository. So really just starting from scratch here. Basically, like next step is like going to register the domain, right? That's how all projects start, is you get that domain started. So there we go. So we have our stupid staking repo. I might even share it in the chat, and it's just going to be like out there already, but let's see, can I do that? Yeah, right here is my stupid staking contract. Okay, here we go. I am going to clone this and we're going to get started. So first step is to git clone your repository, and I can make that a little bit bigger. Then we'll cd into stupid staking and we'll yarn install. And this yarn install is the first step. It's right here in the repo. You can follow this README and it's going to take you through everything you need, including you'll need node version 18 at least, and yarn and git. We cloned it down, we cd'd in, we do a yarn install. Okay, so the first thing it tells us to do once this thing is done installing is fire up a yarn chain. I'm going to bring up another terminal and bring up my code, and let's get a look at the contract as it comes up too. So you'll have two packages here, Hardhat and Next.js. And I know some people get a little tingle on the back of their neck when they see Hardhat here. You have the option. We're working on a CLI right now. Instead of doing this through GitHub, soon you will have a choose your own adventure CLI that will let you pick between some of those 50-50 choices we have as ETH developers. One of those choices will be Hardhat or Foundry, and you'll be able to choose which one you'd like to work with. Right now, I'm just going to have Hardhat here. So we've got a contract. So Scaffold ETH2 starts with a kind of demo smart contract and a front end that comes with it. Okay, and if we get in here, we can kind of look at what this contract is. And then, whoa, I don't want to do that. And then let's go ahead and fire up our front end too. So I think if we look at the README, I think we need a yarn start is the next thing. And that's going to give us our local web server. And this is kind of the key here, that you have both a smart contract you can tinker with and this like front end that you can be able to interact with your contract and see your changes kind of quickly. So let's go look at that. If I go to localhost 3000, we hopefully will have a Scaffold ETH2 app up and running. All right, there we go. So we've got our Scaffold ETH2 app here, and we've kind of got our smart contract over here. And what I want to do is make some changes to my smart contract and show that they're going to update live over in this debug contract tab. So there's no contracts found yet. Let's go ahead and start deploying. So let me make this a little bigger. Yarn deploy. Okay, so we did a git clone and we installed it, right? We did a yarn install. We did a yarn chain to bring up our chain. We did a yarn start to bring up our front end. Now we're going to do a yarn deploy, and that's going to deploy our smart contract to our local chain and then inject it into our front end so we can see it over here. There we go. Cool. So we get this kind of like nice user interface. There we go. Awesome. Good to see some chats here. I'm not like really seeing a ton of chats. It looks like everybody's okay. If you have any questions, shoot them out. But here we go. Oh, I'm in. Oh. Less is less like CSS. I don't know that much about less, to be honest. I think that like if you are a coder and you can think kind of in how things can be written, smart contracts are actually really simple. Like smart contract code is very simple, and that's, you know, by design. But smart contract systems as a whole are very, very complex. But I think you can get started with just a little bit of programming knowledge, but you probably shouldn't be YOLOing to mainnet or something until you really have a good understanding of things. But here is our smart contract. Let's just look at what we have so far. So there's like an owner that we're keeping track of. There's a lot of primary data types here, right? We have owners, we have a string, a Boolean for premium. Okay, so this is interesting. So he's got this greeting, and then there is a function to set the greeting, and and if you set the greeting, it basically like updates that string, gives us a nice console log so we get some feedback, and then hopefully that's big enough for y'all. And then this is really interesting. There's like a check to see if there's value, right? It's a payable function, and if there's value, it sets this premium flag. So this is kind of interesting. Maybe we can dive in and play around with this a little bit. Let's see. So get the initial contract. Okay, yeah, so let's try it. So let's see. Let's try calling this set greeting function on our smart contract. So I'm just going to set the greeting to hello world, and I'm just going to hit send here. It's going to give us an error. It's going to say something like max upfront cost. Sender does not have enough funds, right? Okay, sure, we need to get some ETH. And there's this nice button over here in the top right that gives us money from the faucet. Just to show that again, I can kind of grab my address from Rainbow Kit and dive into this faucet, and I could do it a different way too. So here's sending a whole ETH, right? There we go. So now our character up here in the top right has, you know, $3,000 or something. That's pretty cool. So now they should have plenty of gas to be able to call hello world. Let me zoom in once or twice to give this a little bit more zoom. Okay, so we're going to call set greeting with hello world and send. There we go. Notice no pop-ups from MetaMask, nothing like that. These are burner wallets. These are meant for you know, developers building locally and getting in this nice feedback loop. Oh man, I have no. Someone's asking about node modules, but I have no idea what the answer to that question is. Maybe hit the README or get into the Scaffold's chat, and you can ask some more. It looks like node modules problems. That's kind of you'll have to debug that. Okay, so I called hello world. I was able to set the greeting, and if we go look at the greeting now, it's set to hello world. Let's say hello world again, right? And I could send another one. And there we are. We're successfully calling this function and updating this state. And there's even like a counter and some other stuff, but we're able to do that from the debug tab. Let me jump over just to the example UI real quick just to show this. So eventually you're going to build like a full app with Scaffold ETH, okay? And you want to have a really nice looking UI. So we have this example UI that calls this same set greeting, the same thing we're doing over here where we're debugging, we're trying things. I just want to show that eventually this can be used to build like a production level app, and you can build something you know, that doesn't look like a nerdy debug page. Let's say hello 3 over here, right? Hello 3, and hit send. And this time it looks like we paid some gas and it updated. There we go. And we see it update. We see the count update. Hello 5, I guess, is the next one, right? There we go. And then we see it update. So eventually this stuff that you're building here with these smart contracts can have a really beautiful front end. But let's roll back over here to this process here, where you can make small changes to your smart contract and you can interact with it over here with Scaffold ETH. Okay, so let's see what's next. Maybe burner wallets. Yeah, let's talk a little bit more about these burner wallets. So in this case, I have this wallet right here that is setting the greeting. And oh, actually, let's set the greeting one more time, and let's do this premium thing. So if I set the greeting, let's do set greeting 1 and I hit send, you'll notice that the premium flag is false, right? It's checking to see if there's value and flipping that bit if it does have value. So let's do set greeting 2, and this time let's send in a little bit of ETH. And you'll notice you have to hit this star right here. This is built for developers. I want you as a developer to understand that you need to hit this little button and convert this from ETH to Wei. That's the most important part. I just want to see that. It's really goofy that you do that, but we do that on purpose because we want you to understand that as a developer, you're sending this in as Wei. Of course, when you go to this stage and you have a nice UI, all of this stuff is going to be kind of hidden to your user. But you as the developer, as you're tinkering, of course, when you say hello world premium and you do this 0.01, you have to hit this button and take it to Wei. And if we send that in, there we go, hello world premium, and our premium bit flipped. So we see that that's true. So there you go. We're able to tinker with our contract. We're able to tinker around. Now I think let's look at those burner wallets. So out of the box, Scaffold ETH is going to have burner wallets. If I go to localhost and notice I'm in incognito here, I kind of get this like pink and blue character compared to this like blue and green character. And if I go ahead and just like close that and I open up a brand new incognito window and I go again, notice I get another one. It's kind of like purple and green, right? So we're getting a brand new account every time I'm opening this up because these burner wallets are stored in local storage. So if I wanted to, maybe grab this guy's address and come over here from the faucet and notice that nice like blocky preview lets me know that I'm, sending to the right person, and we'll just send in a little bit of ETH. And there we go. So now this burner wallet has enough money that they can interact with the smart contract or something like that. Let's say hello from the burner, right? And the burner could even pay a tiny bit amount of money. Oh, whoop, I didn't hit the button, right? Boop, there we go. It's got to go ETH to Wei. And then we send it, and sure enough, hello from the burner, and it was premium because we paid a little bit of money, and it increased the counter. And if we go reload over here, we'll see that hello from the burner. So even this burner address is able to get to that. And this is really, really handy if we do something like an ownership pattern. And maybe we can get in and do that next. Yes, okay. So if we're looking at this, there's money starting to accrue in this contract, right? Don't do that. Don't go to the contract. Was that on mainnet? Yeah, don't go to this contract on mainnet. It is a a developer contract. Okay, let's see. So what I want to do here is I need to get this money out of here. We've basically loaded this contract up, and I want to show that we can withdraw it. And there is a withdraw function, and it says is owner. And if I try to call withdraw with this account, it's not going to work because I'm not the owner. Right? And I think we can see this ownership pattern. What's it doing? Okay, so in our constructor, we're passing in some owner, right? So if I go ahead and just make this dude the owner, I'll copy his address, and then I'll go to our deploy function. Here is where your contract is deployed. I can just go in here and be like, yo, let's set that dude as the owner, and then let's redeploy this contract, right? Yarn deploy. And there we go. Now, if we go look at our contract, we've got a brand new contract out there, and now we're the owner. Now we're in control of it. So we can withdraw from it. So let's say someone goes and they set the purpose, they set the greeting a bunch of times, and they send some money in. I'm just going to send money directly from the faucet into the contract. But if we look here, we're going to see that there's a whole ETH sitting in the contract now. And let's watch what happens. So I have 1.9 ETH, and there's 1 ETH in this contract. Will I be able to withdraw and pull this money out? I did. It worked, right? 0 money there, 2.9 ETH there. And let's see. And if there's a bad guy and he tries to withdraw, what's going to happen? If he goes here and he goes withdraw, it's going to say, not the owner. You're not allowed. Get out of here, right? So we've kind of tested this ownership pattern that we have in this smart contract, where we have this modifier that says is owner, and we've added that modifier to the withdraw function. But Look, I mean, this is kind of lame. We're kind of writing our own and we're kind of rolling our own auth, right? I don't know if we really want to roll our own. What would it look like if we import this from Open Zeppelin? And this is going to show inheritance. And also, if you're a new builder kind of getting into things, going and looking at those Open Zeppelin contracts are really enlightening. So we're going to add that. We're going to say is ownable, I think. Yeah, something along those lines. We don't need to track an owner anymore because it's going to be tracked in this ownable that we inherited. Let's see, what do we got? What do we got? There's something happening in the constructor here that I think what we want to do is eventually we will transfer the ownership, right? Yeah, something like that to the owner. And we'll be passing it in just like we are here. But instead of controlling the owner ourselves and building our own modifier, I can go ahead and just delete that. We'll have a modifier that we bring in, we inherit, and it's only owner, right? And then what do we need here? We'll have to do like owner.call, something along those lines. Yeah, there we go. Okay, let's see. Does this deploy? Let's deploy a new contract. You kind of want to get in this loop here where you make small changes to your smart contract, you deploy a new contract, and then you go tinker with it in Scaffold ETH. Notice that since we added this new, we inherited this new ownable stuff, there's a bunch more functions that show up, right? This UI is a little bit more complicated. We have our set greeting and the stuff we already had, but there's also this transfer ownership, right? So what if I like transfer the ownership to Vitalik? Let's see what happens. So first of all, I am the owner, yep, and transfer ownership to Vitalik. Let's see if this works. Yeah, cool. Okay. So now Vitalik is the owner of my contract. That's pretty cool. Okay, let's deploy a new one that Vitalik is not the owner of. Oh, it's going to reuse it. Okay, here's a new trick. If it's ever reusing it, you can do a -- reset, and this is going to give you a fresh contract. There we go. That's not owned. There we go. So there's our contract back that we own, and we can go tinker with it. We could go set the greeting. We could withdraw funds. It looks like everything is working well there. And we're able to withdraw. We're able to bring in inheritance. It was used in address input. Okay, so now it's really time to tinker. Whether you are an expert at Solidity or not, you're probably not going to just sit down and know exactly how you want your contract to look. Usually you'll sit down and you'll need to tinker and you'll need to figure out how you want it to work. So now that I've showed you kind of how this little pattern works and how some stuff works, let's really get into it and start a new contract. So I'm going to call this the stupid staker contract, right? It's going to be a, let's see, let's just grab some stuff from here. We'll probably need both of those. And we probably need some kind of decay, something like this. I don't know. I don't need all of that for sure. Do I want them to be able to even send in money? I don't think I do. Yeah. Okay, I'm pulling everything out. Here we go. It's not even going to be ownable. We're going to call it stupid staker. And yep, this is the whole contract for now. Let's just make an address public. Owner and set it equal to me just to prove that like things are deploying and it shows up in the front end and all that stuff. There we go. And maybe we don't have to call it owner. We can just call it Austin burner, right? This is my burner. There we go. And now we need to deploy this thing. So we'll go to our deploy script and we'll copy that and we'll do simple, like stupid staker, even worse. Okay. And we won't have any arguments. Let's see, does this thing deploy? Oh, I did a -- reset even. There we go. Boom. There we go. Our contract. So your contract and stupid staker is deployed. And then look at this. Now we have this new tab. So now when I click this, there's our stupid staker. There's no read methods or write methods yet. This is a really nice touch, Carlos. Good job. But we do see that my burner is basically, or Austin's burner is being tracked there, right? We can track that it's Austin's burner. And maybe we could make a function that only Austin's burner could call. Okay, so now we need to start tinkering with our contract. What I want to build here, and this is stupid. Don't try this at home. I don't know what I'm doing. I'm just showing off this tool. We're not really building anything in production here, but I want to show you that you can build something in production. I want to know if bots will learn how to call a function that is for sure going to pay them in the future. And I don't think they will at first, but maybe they will. Like this would be super expensive to put on mainnet, but we could. But what I want is, let's see. So I do want you to be able to send money straight into the contract. So I'm going to add that receive function and stick that in the contract. Okay, let's test this. This is fun. This is a great thing to test right now. Could I send money into the staker? Wait, it's really weird that this looks so similar to this. It really shouldn't. Okay, so let's see. I want to send money into this staking contract. This should actually fail because there's not a receive function in the contract yet. I haven't saved this yet over here. So when I hit send, it says no receive function, right? So before it was just like this. There's no receive function in the contract. Now we add a receive function, we hit save, we hit deploy, and this is our feedback loop. We're testing things. We're not writing like all these complex tests around this. We're just testing them live to see if it works the way we think it's going to, right? And sure enough, we get a new contract. And now can we send money to it? Let's see. If I go here and I send one, yeah, there we go. It went in, right? If I hit reload, yes, there's 1 ETH in the contract now. So this new line basically allows the contract to just receive ETH. People can YOLO ETH to the contract. It doesn't do anything. It doesn't execute any code. It just like accepts the ETH, right? We could revert here, right? Or something like that. And then if you sent money, it would revert always. But it's always going to do that without that line there anyway. So that would not work. That not be important. Okay, so we're going to put a contract out somewhere, and we're going to upload. We're going to let people call some staking function, right? So let's say there's some money in this contract, and there's going to be a function called stake that is going to be public. I think it just tried to write it for me. Public. Let's let the AI. There we go. Okay, cool. And we have like a console log. Fine. Let's go with it. Let's see that works. Okay, cool. And it's payable, but we're not requiring anything, but fine. Like someone should be able to 0.01001 convert that to Way and stake. Sure, it works. And did we get that console log? Yes, we did, right? We get that nice feedback. So kind of just like one step at a time, we're building this simple little staking contract. Okay, so I don't really want a console log. Eventually I'll take that out if I put this on mainnet or something. What I want to do here is probably require that the message.value is, equal to or greater to some value. Let's just say 0.01 Ether. Okay, so you need to stake exactly 0.01 Ether. Okay, so if they don't put in exactly 0.01 Ether, we're gonna revert. So if you get to this point, we know that they've put in at least 0.0.1. Now we want to do something like, let's keep track of a mapping of an address to, yeah, I guess we could keep track of their balance. So they could stake okay, so this is gonna be weird. I really only want them to be able to stake once with a single address. So I don't want to keep track of like some like bring in, if we wanted to, we could go learn about structs, and we would go to Solidity by example, and we'd grab a struct for each time someone deposits, and we'd have an array of those structs, and we would push new ones on each time. Each time you stake, it adds a thing to the array of structs, and then you come in and you withdraw later. I'm going to make this one simple and stupid. This is the stupid staker. So basically, I'm just going to make this a bool, whether or not you are staked. Okay, so we're just keeping track of whether or not any given address is staked. You know what? This should almost be a timestamp even, right? Let's make this a uint64. Like when, and we'll call it when staked. Okay, again, we're just like kind of changing things up and figuring things out as we go. So if this is 0, right, we want to require that this is 0. Yeah, when staked of message.sender is 0, or they've already staked. Okay, and then as soon as that happens, we're going to set the when staked. Oh, look at this. Thank you, AI, helping me out. We're going to uint64 type def the block.timestamp, and we're going to keep track of it, right? Okay, so now we're allowing people to stake only once, only exactly 0.01 Ether, okay? And then we need some other, let's go test it once. Let's go test it, right? Let's go test if this is working. We got plenty of time. We got half an hour. We're just chilling. It's a nice BTF. We're just deploying some stuff with Scaffold 2. Here we go. Let's go make sure that we can stake into our contract, right? So if I reload this, what do we got? We've got a when staked. So that's a read function. And we can see when this person has staked is 0. Okay, so now I do want to stake. I need to stake exactly 0.01. Let's do 0.1 real quick just to have it yell at us. It's going to say, no, you can't do that. Okay, it needs to be exactly this amount, right? This is the same as 0.01, and this should work. All right, it worked. We were able to stake. Now, I shouldn't be able to stake again, right? If I call stake, there we go. You've already staked, right? Okay, so we tested that. And we should also have a value that's staked. Okay, so I think this is working. We're basically kind of setting up this sort of win stake. Let's make a read function. Normally, I would jump right into my withdraw function, but you know what? I'd like a read function here. And this is how I'm kind of iterating between my contract and my front end. How about if we do time staked, right? And we're going to make this, yeah, and it takes in an address and a public view returns. I want to do the block dot timestamp minus the win staked, something like that, right? So win staked is going to be smaller, and let's see. This should give us. I don't know. Let's go find out. I don't even read the code. I just deploy it and make sure it does what it needs to do. Let's see. Let's see what happens. Now, if I go here and I stake my money, and then I read time staked is 0, win staked. Okay, so I have it staked. Okay, but I'm reading 0 here, and the reason is there's no transactions happening on my local chain. What I need to do is just trigger a transaction to happen. So I'm just going to hit this little faucet button in the top right. That just forces a transaction to happen. What that's going to do is going to give me a new block, which is going to give me a new timestamp. And now when I read from here, it's going to say, oh, you're 22 seconds staked, right? Okay, let's do it again. Let's do it again. So let's just hit a fake transaction, whatever, and then go read this. Now I've been staked for 35 seconds. Isn't this kind of a nice little read function? You could have some UI that's just checking how long this person has been staked, right? Okay, whatever. Now it's time to withdraw, right? This is the cool part. So we want them to withdraw. We'll make it public. Okay, let's just go with the AI. So we're making sure that they have already staked, or we throw an error that you haven't staked. We make sure, okay, right here is the time period. How long do we want to make them stake? The UI or the AI wants to make them stake for a week. We don't have time to test that, right? We need to test that live here. So maybe we say like a minute, maybe we say like 30 seconds, right? Can I just say 30 seconds? Just like write it out like that. Wow, okay. You must stake at least 30 seconds. Can you be that patient, Anon? Okay, so and then okay, here we go. Here's where we transfer them the 0.01 back, and we clear out their staking. Okay, now here's where I think it'd be funny to see how bots handle this. If we have some money in this contract, what if we give like a bit of the money that we have in the contract to, I don't know, or some kind of like extra money? I don't want to count all the stuff that people have staked. I just want to count the extra stuff. So maybe what if we have a variable down here that says unit 256, and we'll call it prize pool, right? Oh man, it sounds like we're gambling. This is not a gambling app. This is a developer debugging app. Disclaimer. Okay, so we have this prize pool, and every time someone YOLOs money into the contract, we increment the prize pool. Oh, notice if I were to deploy this right now, watch this. Here, let me save it. This is another gotcha, right? Notice this isn't public, right? And if I deploy this contract and I'm like, okay, I'm trying to keep track of this prize pool, and I'm over here and I'm looking at my variables in my stupid staker contract, and there's no prize pool. What the heck is going on? Oh, I forgot to make it public. Knucklehead. Okay, there we go. Let's redeploy. All right, so what I want to test here is that I can YOLO ETH into this contract, and this prize pool increments. And it's not when I stake. So first I'm going to stake 0.01, the usual, right? Boom, boom, we're staked. There's money in this contract now. Come on, load. There's money in this contract now, but the prize pool is 0, right? But if we YOLO money to this contract from the faucet, let's say 1 ETH, then the prize pool should be equal to 1 ETH now. Yes, okay, cool. So basically, we're not keeping track, or we're keeping track of how much money people stake in one place, and then we're keeping track of a prize pool, how much people YOLO in another place. This is gonna allow us to not give out people's money, right? If people are staking into a contract and I'm giving out some prize funds, I don't want to give other people's stake out to other people, create like, that sounds like a pyramid scheme, Austin. Exactly. I'm not trying to do that shit. What I'm trying to do is see if bots on chain will be smart enough that I'll YOLO an extra prize pool to this staking contract. And then when people take out their money, right, I'll do something extra here. So we'll say if prize pool, let's see, the prize pool is greater than or equal to, I don't know, 0.001 ether. Like if we have some money locked up in the contract, IDK, what I'm doing here, I'm just writing some code. What I want to do is, ooh, yeah. What if we have an amount, right? We have a UNT 256. Oh man, the gas optimizers are starting to shake a little bit with me adding all these new variables. Let's create some kind of prize here, okay? Actually, this will be total payback, okay? We'll say total payback and we'll set it equal to 0.01 ether. Then that's the thing that we're going to send here. But what we're going to do is say, hey, if there's money in the prize pool greater than that, we're going to add 0.01 ETH and subtract 0.01. Oh, perfect. Thank you, AI. That's great. So in 0.001 increments, we're going to add an extra prize when you stake. So you stake 0.01, and if there's enough money in the contract, it's going to send you 0.011. Okay. I don't know. Will the bots figure this out? Now, the key is we don't want to have an owner here. We want this thing to be completely permissionless. Because if you see something, why are you using require instead of revert? Where would I use revert? I don't think I would use revert here anywhere. I think I want to do a require. I think revert like also burns gas. Like you rarely want to use revert, right? I think. Okay, so we're requiring this. Oh man. Okay, now I'm off my. Let's see. What do we want to do? We want to see if bots will figure out that they can get money out of this. Okay, so what I was talking about was like an owner. I don't want to have an ownership pattern because if you saw this out on mainnet and it was like, yeah, you put in money and you get free money back, that's obviously a rug. That's a scam. Someone's probably setting up some kind of like function here called rug. Let's see if it just writes it for me. If I write function rug is the AI, yes. It checks to see if I'm the owner and it transfers the entire balance of the contract to me, right? So you could make it look like people were going to, but then you would rug them, right? I mean, please don't do that. Don't do that. People do that though. Like that, this is the Wild West. Anybody is allowed to build anything and deploy it permissionlessly to a credibly neutral network. So we get a lot of junk and a lot of scams. You just have to do that. That's just a disclaimer on building on this cool technology. But what we want to do is see if bots are smart enough to get the prize out of this pool. And if not, y'all can get in and earn $1 or 0.001 ETH in my app. So let's see. We've got our prize pool. We've got our payback. Let's go test it. Let's go make sure it all works, and then let's put it out on some live network. Okay, so we've redeployed everything. Let's test through that everything works. So let's see. Can I stake 0.01? Grab that. Grab some money. I should be able to pull money out too, right? I can check my time. Oh, wait. So let's see. In the withdraw, I wonder if I kind of want to make this so if they withdraw after 30 seconds, they get paid. And if not, they just get their money back. So technically you could get your money back at any time. And then only would you get your extra money back if you waited long enough. Instead, basically the money is locked in here. I think this is kind of weird, but we're doing it like the money lands in the contract and you cannot get it out for 30 seconds. And that's just how it works. But after enough time is staked, you can, it says 0, but if we do this thing, it's going to show that it's way more than 30. We should be able to withdraw. There we go. Okay, and the money should come out of the contract and go back to us, and it did. Okay, so we can stake and we can withdraw regardless of what the prize pool is. Okay, now let's do this. So I'm gonna create like an incognito window because I want to track the balance like very, very accurately. Okay, so let's have this person only get 0.01 ether. Oh no, they got 1 ETH. Okay, fine. This person has a whole ETH, whatever. It's just enough for gas. Wait, I don't want to do it. I want to send them whatever. Okay, then let's set up a prize pool. So let's put some money into the contract that will be the prize. Okay, now this person will stake their 0.01. Okay, and we'll be able to check their time staked here, and we'll be able to watch it. And if I try to withdraw, it's going to say you have to wait at least 30 seconds, right? So we're kind of waiting for that 30-second period to happen. But what we're watching here is that not only the 0.1 comes out, we're looking that this balance afterwards is the 0.1 plus the 0.001, right? We should get a bonus. We should end up with more money than we staked. And let's see what happens here. If I hit withdraw, it'd be nice to have like a block explorer. We can see the prize pool goes down, right? It did work, right? The prize pool went down by 0.01. Now the balance is the 0.1 minus, I wish we could track this a little closer, but we do have even more money, right? We have more money than we started with. Let's see, how much did we gain there? We got our 0.1 back. Wait, I feel like I got more than I was supposed to. Maybe not. 0.01, right? We stake it. I wasn't tracking the balance very closely, but making sure it sends back the 0.01. Yeah, I think it works. Maybe we should test this a little bit more. I feel like I want to watch this person's. Yeah. No, that's right. Okay, and he had a little extra. Okay, I feel like this is working. Of course, if you were going to mainnet, you want to now spend a whole lot of time writing tests. If you get into hard hat, you have these test scripts here. You want to test all the things we've tested, but you want to do it programmatically. Make sure only the owner can do this. Make sure this person can do that. Make sure you can only stake the amount. You can't stake the other amount. All the little tests we did here, kind of like brute force, you now want to kind of have in a programmatic test suite. You want to get an audit. You want to do lots of other things that I'm not going to do here. I'm just going to kind of YOLO this thing because I'm going to test it. It's a small test, low stakes. But also, you probably shouldn't be YOLOing to mainnet. Don't try this at home. Okay, let's say we want to deploy this thing, right? We've got it working. It kind of looks nice. You know what? We probably need a staking button. I'm realizing that we need a little bit of UI, right? I don't want someone to have to use this debug contracts tab. Oof, we're going to cut it tight here, but I think I need to build a button that lets you stake, right? And so what you can do is you can go look at the example UI code. If I go to, let's see, if I get out of hard hat, go to Next.js, look at our pages, look at our example UI. This is going to be handy because it's going to kind of teach you, let's see, contract interaction, contract data. We can kind of get in here and look at some of these components. Let's see, example UI. There we go. Contract interaction. There we go. This is how you write to a contract, right? There's the hook. And contract data. This is how you read from a contract, right? Yeah. Use scalpel. This is how you listen for events. So all this kind of like front end stuff that you need. How do I read and write to a contract? How do I get the logged in user? All of this stuff is here as an example in the example UI. But what I like to do is go over to this index page and just kind of like carve everything out of here and just kind of start with something like this. Let's see. What's this look like? If I go over here, now we have this home page, nice and clear. If I do like, hello, let's just call it stupid staker, right? Do we get that? Oh yes, that is very nice. Okay, and let's see. First thing I want to do is show logged in user, right? So we will say const, and it's going to be something, and this is going to be equal to use account, I think, right? We'll bring that in from WAGME. It automatically imported it. I'm going to go ahead and pull these things out to avoid type errors later. I think this is data goes to account. I think it's something like our address, right? Wait. Nope. Let's just find out. What? Nope. Which button is it that tells me? I'm pretty sure it's data goes to. Nope. I'm just going to say address. It must be address. Here, WAGME docs. WAGME get logged in address. This is one way to do it. It's not the best way to do it. I should definitely command click. Command click is what command click into this and go find out is what Carlos is telling me in the chat. DK, that looks like a lot of stuff there. Okay, WAGME. Nope. I want to just get the address of the connected wallet, right? Yeah, right here, right here. Here it is, use account, right? And you get the address. Oh, I'm doing it right. I'm doing it right. I don't even want to know about is connected. I just want use account. And then I want to display this address with an address component. So Scaffold ETH comes with a bunch of components out of the box. Let's see, address, and we need to bring this guy in. We need to import from Scaffold ETH. All right, let's go hit save and see what our front end looks like. There we go. Now we have Stupid Staker. We have the logged in user. If I were to go disconnect and connect and use my MetaMask, there we go. It's got me logged in there. Okay, so maybe I want to read from the state, something like that. But right now I just want a button that lets me stake. Okay, so let's bring in a button that lets me stake, right? And we'll do something like on click. We're going to call some function, right? We'll figure that out in a second. And we'll do class name. We'll do some tailwind here and get this thing looking nice. It needs to be a button, right? Primary. Yeah. Yeah, I'm doing some CSS. I'm doing some styles. Uh-oh, what did I do wrong? Stake. I've got a closing tab missing somewhere. Oh, really? Do I need to do this right away? See, there we go. Now we've got a stake button. Okay, what do we want that button to do, right? We want that button to call this function over here. We want this to call this stake function and send some value. So let's do this. Let's do const, and we'll figure this out in a second. It's going to be use scaffold contract write. Okay, bring this guy in, and it's going to hopefully, nope. Let's see. Yeah, no, I do want contract name, right? Yeah, contract name is going to be stupid staker. And method name, I don't think it's method name. I think it's function name. Oh man, come on, AI. Is stake, right? And some args. It's just that is so bad that it's filling that in with that. And what I want to do is send some extra value with this. And I don't know actually how I do that with this. I wonder if I just pass it in here. Let's try it. Let's find out. Right. And I want to do ethers, utils, parse ether, and some amount like 0.01, right? And it wants me to bring in ethers. Let's import that. Okay. I have no idea if this is going to work. Whoa, it doesn't like our args. Oh, let's take them out. Is it one of these where I, what if the value is just this? Any chance that's going to do it? I have no idea. Let's find out. Okay, now what we want to do, I think we get like an async. Yep, he's doing. Yep. Okay, cool. So I want to get this write async from here, and this will do stake, right? So I've created this function that's going to call the stupid staker contract with the stake function and send in 0.01, right? We're going to stake 0.01 ETH, and then there's this write async, this do stake, and that's what I'm going to call down here, right? Do stake. Okay, let's see if this works. All right, here we go. Let's reload this. We've got our stupid staker here. Let's see what happens when I go push this button. Oh, wait, it's me. I want to log out as me and get in as this burner wallet just so I don't have to deal with all those pop-ups and stuff. There we go. Transaction completed successfully. Okay, so we probably want to read something too, right? Something about our amount staked or something like that. How about time staked, right? If we could go read time staked from the contract. So I want to use scaffold read, and it's going to be the same thing. We're going to say, let's go ahead and import that. We're going to read from the contract. Actually not function name, it's going to be time staked with args the address. Okay, and then the data will be our time staked, and then we'll put that down here somewhere in its own like ugly div. Cool. Put like a little S on that. Okay, it's going to be hard to get to deploying here. We don't have very much time left, but let's see what we have here. Do we have a working app that lets us stake and see? Oops. Oh, that should be maybe 2 number. Oh yeah, time stake 0 seconds. Okay, you got to do that. You got to do the thing where we increment it. There we go. So now we see that we've staked. Okay, and then what do we need? We need another button that's like unstake, right? And let's see, we're going to call a different function, which is cool. I can just copy this thing now. There's not going to be any value here. What's that function called? It's called withdraw. And let's do some tab completion here. I think I can do command space, and it's going to give me all the functions here. Yeah. So withdraw would be here. Oh, let's see if there we go. Look at that. There we go. It tells me exactly the functions of the contract. It goes and looks it up thanks to type safety, and we get that withdraw first. Cool. Okay. Sorry, just checking chat real quick. Withdraw. Okay. And I don't think there's anything else that goes into that. This would be like undo stake. Okay. And we put that in here and we hit save. Is everybody happy? Do we have an app that lets us? Now, if we unstake, yes. Okay, cool. And then this restarts. Ooh, that's a weird. Whoa. Why did it go to? That's a weird. Oh, because it's looking at the block stat -0 because you have 0 stake. Okay, whatever. It's ugly. It doesn't work, but we got to get this thing deployed. We only got 10 minutes left, and we want to put this thing out on a network to see what happens if bots are going to take some money from it or not. And let's also YOLO. So if we go to the contract, there is some ETH already. We'll need to remember to YOLO some ETH to it, so there is a prize pool. Okay, here we go. Now, are we ready? Are we ready to deploy this thing to a different network? Right? It's all been local host right now. How do we put this thing out on another network? Let me check to see if we have any. I feel like there's going to be some type errors here and there that I just want to get ahead of. So do a yarn next, check types. We got to do type safety, make sure this thing, we can commit it. I just want to make sure it's all cleaned up. Whoa, yikes. Okay, might have to ignore that. Let's see. And what's the next? Lint, right? Make sure we got that. Weird type error there. I'm not sure if I can get around that one. Okay. Yeah, we can also go around. Like there's a lot of type safety here where it's going to say if we have any type errors, it's not going to let us push this thing, but we can kind of also push that thing. But we can do a no verify. Okay, we need to deploy this contract though. We need to get a contract out on a network. How much is this going to cost to put on mainnet? If I do a yarn deploy -- reset, it's going to give me kind of the cost of this thing. It's actually not that expensive. I mean, it's sort of expensive, but let's see. And I don't want my your contract to deploy anymore, actually. I don't want to pay for that if we put this out on a network. So let me go up and go to our deployment. And I'm probably just going to comment this out. Oh, man, I don't know if this might break something. Let's find out. Let's do a yarn deploy -- reset. Hopefully it only deploys the stupid staker. And if we go look over here, like, yeah, the example UI is going to stop working because that contract's not there anymore. But the debug should work. Whoops. Localhost 3000, stupid staker, debug. Okay. So our contract does deploy and it doesn't have the your contract anymore. It's just the stupid staker. Okay, we want to put this out on a network. How do we deploy this now to a public network? So what you need to do, and this is in the docs, but you have to do a yarn generate. And this yarn generate is going to create a deployer private key. It's going to stash it away in an environment file. You're never copying, pasting private keys around, right? We're creating a deployer just for this project, just in this repo. We're never exposing it or seeing it or anything, but a yarn generate sets that up for you, and then a yarn account shows it to you. So let's see. I'm going to use a Punk wallet built with Scaffold ETH. I'm going to use some wallet here, and I'm going to send some value to our deployer. What network are we going to deploy on? I don't know. I let me see if I have some optimism. I have $173 worth of optimism in my Birder wallet. I think that's a sign that we should try this on optimism and see what happens. So this contract is probably going to cost like $20 to deploy or something. So I'm going to send that in first. So here goes $20 being sent on optimism to this character here. Hopefully it's there, and I can just do yarn deploy -- network optimism. Here we go. Here we go. We're going live. Are y'all ready? Bow Tie Friday. We're going live. Here we go. Ooh, please work first try. Stupid staker getting deployed on a live network with real money. Don't try this at home. It's deployed. Okay, so now we have to make one other change. We need to go to our scaffold ETH config, and you'll find that in your Next.js. But this thing is controlling the satellite, where your front end is pointed, right? And right now it's pointed at hard hat. That's localhost. Don't put in localhost, put in hard hat. That's localhost. Okay, but we don't want localhost anymore. We want optimism. We are out on optimism. Woo, woo, woo. I'm gonna set my polling interval to like 5 seconds, so it's a little bit faster. And let's see what happens. There's our app. There's our smart contract. It's out on Optimism, and now you'll notice that the network is Optimism. Let's go ahead and connect in some wallet. Okay, now we want to use our MetaMask, right? Now we're out on a public network. Now you want to use that MetaMask. That MetaMask is great for this public network, or you could wallet connect in your Rainbow or whatever you do. But here we are. We've got some Optimism. I could stake right now. I could do this. Okay, I am going to. We need to YOLO some money in still, okay? I'm going to copy this address. I got to send in a little money here. Okay, I think I copied it. Let's see if I paste it in. Nope, I didn't. Oh, darn it. I deleted it. It was working, and then I didn't. All right, let's paste in this address. Yep, looks good. All right, I'm going to send like $50 maybe? Oof. Don't do this in production. Don't try this at home. I'm just throwing money at the bots probably. What's going to happen is hopefully we get a little prize pool here. There we go. Now there's a balance in there. Oh, that prize pool. Yes, there's a prize pool. There is a prize pool. Okay, you can stake Optimism, and if you wait 30 seconds, oh, we should have made it longer. Staking for 30 seconds is so cheesy, but I guess it's good enough, right? So I would think that if the bots were smart enough, this money should just disappear right now. Basically, a bot could create a bunch of accounts, put in the needed ETH, know that it's not going to disappear and it's not going to be rugged because you can see in the contract it's not going to be rugged, and then pull the money out. But I think I'm like way too optimistic about a bot's ability to figure this out. So what I'm thinking is let's do it once. Let's go through the actual staking with a live account, and let's see if a bot picks up that this is a thing that it can do. Probably not. We're over on an L2 also, so who knows if like the bot ecosystem is similar. But let's stake. Oh wait, what am I doing? Why am I using the debug UI when I have this gorgeous UI over here? Yes, I would like to stake. All right, and it's going to stake $17. Okay, so I'm putting in $17.71, and I'm paying probably $1 or $2 in fees. But I'm going to make 0.001 back. It's going to happen. Okay, so how much did I start with? I should have been paying attention. 500. I should have been paying attention. Dang it. Maybe I need to connect in as another one. We got 2 minutes left here. Time staked is now 15 seconds. We're waiting for this, right? Boop, boop, boop. Okay, so I need to push this thing out to production. I've deployed the smart contract, but I haven't deployed this beautiful front end. And what I want is to put this beautiful front end out here. Now, what I could do is I could do a yarn Vercel, and I could ship this thing. I could just type yarn Vercel and I could ship it. But what I'm going to do is I think I want to commit it. Let's just do it. We don't have much time. Yarn Vercel YOLO, right? We're going to YOLO this thing. I'm just going to say yes to all this stuff. Quickly, no, this is called Stupid Staker. Wait, I did not read that. Stupid Staker. Yes, go. So we're using Vercel here, right? This is Next.js, TypeScript. Let's see if we can unstake. No, ship it. Come on, I need a backend. There we go. I think we're going to run like a minute over. I apologize to y'all. If you hang around for 2 more minutes, you're going to see that there's going to be a live website that y'all could go to and put your ETH in on Optimism and get back some money. But it probably doesn't even cover gas costs now that I think about it. I should have done a longer staking period and a larger reward, but you can go fork this. The code's all live. Let me see. Can I get committed? Let's see. Git add. Let's add the staker and commit it while we're waiting for. Is it working? And I'm going to commit this with a -- no verify. Sorry, Carlos. There we go. And I'll do a push, right? And that should push to the stupid staking thing. So yeah, so this code is all out there. You can totally just grab this repo and extend it if you wanted to. Really, you should probably just get started with Speedrun Ethereum and Scaffold ETH. And again, like, notice all that tinkering that we did. We picked out our contract and we didn't know exactly what we wanted to write yet, but we got in here and we tinkered with a contract with Scaffold ETH2. And then once we had it working the way we wanted, we shipped that thing all the way out to a production endpoint. Okay, so now I should be able to unstake. Let's see what happens here. So let's see. Let's go look at, if we do a debug, we can see the prize pool is at this. I kind of want to look at this. So 0.0281, right? So it's at 0.028. And if we unstake, let's see what happens. Okay, I want to create a new character real quick. I want to create a burner wallet. And I want to go stake and see if the money shows up. Oh, stupidstaker.vercel.app. It's live. Okay, let me give you guys a QR code. Let's do this even better. Let's go to ETH build. We're going to create a build. There we go. There we go. Stupid staker. If you shoot that with your phone, oh, I could just do it with my phone. Here we go. Here we go. I'm gonna go stake some funds. Now then you can't see it on your phone. But there we go. Stupid Staker is now a live app that you can connect your Rainbow wallet to on Optimism. And it went from something we were tinkering with to a stupid live app that's out there, and there is $50 to claim from it if you're watching closely. Real quick, are we okay for time? I'm just gonna do this real quick just to check. So what I'm thinking is I'm gonna create this burner wallet. Ooh, I can't. Okay, so no, I'm gonna do it this way. I'm gonna wallet connect in my Punk wallet. Okay, so I just pull up punkwallet.io. I select Optimism, so I have a nice little red scanner there. I click the little red scanner. I zoom the thing. Now I'm logged in to this app as this guy. Okay, I'm logged in as punk.austingriffith.eth. Okay, and he has exactly $100.47. Okay, now he stakes and he'll get a little transaction up here. And I say, yes, I would like to stake without reading it at all. Thank you. And it, waiting on wallet connect, waiting on wallet connect. There it goes. There it goes. All right. There we go. Now we're down to $82.25. So we had $100 and some, right? I know, I should really pay attention closer. All right, we staked. We need to wait. If we try to unstake, it's going to tell us, no, you can't yet. It hasn't been 30 seconds. Can't yet. Come on, Optimism, give us a block. Give us a block. Here we go. Unstake. Oh no, oh no. Wait, like more than 30 seconds? Is it greater than? What does it look like in the contract? Oh yeah, it's greater than 30 seconds. So if it's exactly at 30 seconds, it's not going to work. There we go. Now we're ready to unstake. We get another transaction up here. I say okay. It loads. Did I say okay? Yep. We're waiting on wallet connect. There we go. Transaction went. Okay, and we reset. Look at that. We made $1. Woo! Look at that. We made like $1.20 or something, right? All right. Now, come on, bots. Where are you at? Like, obviously, I would say that a bot would see this as a honeypot. Like, money goes in and one account gets money, but when I put my money in, you're gonna rug me. So probably, like, I could see why bots wouldn't go get this money. But is it I gotta verify this. We gotta verify this, right? Let's try it. Yarn verify network optimism, that contract. Let's see if this works. Oh, darn it. Oh, maybe I don't need that. argument. It would be kind of cool if we could see the source code live. So, oh no, yeah, I'm gonna have to put in an API key for Optimism. Oh yeah, you were Yarn YOLO. Yeah, I think I'm gonna have to put in an API key to be able to verify this on Optimism, and that's probably one reason why a bot is not like just emptying the contract. Wait, is the contract? Oh no, it still has money. I saw zeros there. I was like, it happened, but that was just a old load. Okay, so let's see. Is this dude? Let's see. Let's go back here. I don't know what that one was from. Where is, okay, yeah, here it is. So the contract isn't verified. So I could see like this is an unverified contract. There's still $46 in it to be taken. And anybody can basically go to stupidstaker.vercel, connect your wallet, put in $17 worth of Optimism, and after 30 seconds, withdraw $18 worth of Optimism. I would say you probably shouldn't do this. like disclaimer, don't use this. Like this was something I just deployed. Like who knows if this contract is secure. The goal here was to show you that we can go from 0 to 1. You can start with something like Speedrun Ethereum. You can start by tinkering with Scaffold ETH and Solidity by example, and really kind of figure out what you want to build. And then you can get that thing built. You can tinker with it using debug contracts. You can eventually have a beautiful UI, but you can have an ugly UI to start, and you can get that thing all the way out to production, not just deploying the smart contract to a production network, but we also deployed this production app, and it's live at stupidstaker. I don't even know. I can't spell stupid. Stupid-staker. There it is. Yeah, stupidstaker. .vercel app, I think is it. Yeah, there it is. Boom. I was even able to type it in after a lot of try. So happy Bowtie Friday. I see a hug in the chat. Hugs, hearts. Happy Bowtie Friday. I hope this was a lot of fun. Go try out Scaffold ETH 2. There's a lot of this stuff I did here is covered in the README there, but ask questions, try it out, go build something cool. Let me share the Scaffold ETH 2. If you just Google Scaffold ETH, I think you usually end up at Scaffold ETH 1, but Google Scaffold ETH 2. Let's do it. Incognito, Scaffold ETH 2. What happens when we Google it? Oh, we get it. There it is. That's it, right? That's what you want. Let me paste that into the chat one last time, just so you have it. Woo! Okay, I think we're done. I think it's end of Bowtie Friday. Thank you for having me. Thank you for showing up. Thank you all for sticking around this long, hanging out, and being part of this. Go hack at the Chainlink Hackathon, right? Go build things. Hopefully, this is a great hackathon stack, and you can go build things with this stack. All right, hearts. Thank you very much. Anything I need to do? Any closing remarks? Anything else? Boop. Okay, I'm not seeing anything in the chat. Hearts. Thank y'all. Happy Bowtie Friday. Go build something with Scaffold ETH. See ya.